let's go for it. Good morning, everybody, and thank you for joining us today for this webinar, where we'll be taking a look at intelligent components integrated into the BMS to make it easier, more cost-effective, and high performance for the BMS to control window automation and intelligent natural ventilation. It's proved quite a popular topic again, another record sign up, so hopefully it'll be a good session, and yeah, hopefully get some good questions towards the end as well. So just to get us started, a quick introduction then to the session. Should be approximately 45 minutes, and the plan is that we'll have a Q&A session at the end, so feel free to use the chat box and raise any questions as we go through, and then any that we don't answer through the rest of the presentation, we'll take some time out at the end to see if we can address any queries or questions that you've got. My name is Tom Lim, and I oversee the UK and Irish organisations on behalf of WindowMaster, and there's my contact details, and they'll also be available at the end, so if there's anything that I can help with, feel free to contact me. So what are we going to talk about today? We're going to be talking about the latest intelligent components that make it easier for the BMS to take control of window automation, and ways of simplifying the system to make it easier to deliver, easier to achieve a high level of performance, and to do it more cost effectively. So we're going to take a quick look at the growing demand for window automation. We'll have a quick look at some of the common challenges as well that I'm sure some of you guys will be familiar with, and the different approaches to controlling actuators. We'll take a look at the traditional kind of system architecture, and then ways in which we can incorporate intelligent components to make that easier, and that are compatible with any 24-volt DC window actuators, and actually can help achieve cost savings as well. And then of course we'll have a quick look at sort of specialist input that we can offer to make that process all the more easier to achieve the right results first time. So I'm sure you guys are already very familiar, but why are we seeing more window automation? There's been some long-running themes, of course, with increasing focus on sustainability, reducing carbon, making our buildings healthier, making them more pleasant places to be in, and of course using as little energy as possible. And then there's some emerging themes, of course, pandemic resilience for both existing buildings and for future buildings as well, and planning for potential challenges in the future, making our buildings more adaptable, making them smarter, and using things like intelligent facades, the BMS, Internet of Things, big data and AI to really make our buildings perform on point and make them do the best job that they can, to make them great places to work and learn in while using as little energy as possible. So where does natural ventilation fit into that? Well, I mean, it's been around for forever. We have a really good understanding of it, but I think it's really coming back into the fore in terms of new building design, and also making the most of the natural ventilation potential that we've got in existing buildings. Natural ventilation can improve the amount of fresh air that we have in our buildings. It can cool buildings passively for much of the time. I think we're the envy in the UK of many other countries in terms of our climate. It lends itself really well for using natural ventilation most of the time. You know, we don't have really hot summers and we don't have really cold winters, so we're in a perfect position to use that as much as possible. We can reduce, by using natural ventilation, we can reduce our dependence on mechanical ventilation systems. We can help to reduce their runtime by naturally ventilating the buildings most of the time. We can use intelligent strategies like night cooling to reduce the load on those mechanical systems should they have to come into play to load lock and take the peaks off temperatures in summer. But ultimately, natural ventilation can help to reduce carbon and the running costs of buildings. It also can be one of the more challenging applications for building automation and for the BMS. So in order to make it work in harmony with the occupants and with other building systems as well, like heating and perhaps in a hybrid arrangement, it's really important that we understand it, and that we control it properly. And there's a lot more emphasis on that. And fortunately, WindowMaster technology really helps us to achieve that, and our experience can help support everybody in this process. So we spend a lot of time with architects, with consulting engineers, and with BMS companies, helping to deliver the most cost-effective and high-performance solutions appropriate to the building. And you'll have seen probably in the press recently a lot of focus on natural ventilation. So there's a comment here from Susan Roth, head of architectural engineering at Heriot-Watt University, that the future will have to be about buildings that are naturally ventilated for as much of the year and day as possible. And then there's a number of other thought leaders from the likes of Chapman BDSP, Borough Happold, and Foster and Partners, who are all talking about the relevance and the importance of incorporating as much natural ventilation into our spaces as possible. And that's to achieve our zero carbon aspirations, but also to make our buildings healthier. And this is by no means a new technology. It's been around for some time and it's been delivered in varying degrees of success, but I think it's fair to say that the technology available to us all today means that we can do a really good job of delivering optimum performance in buildings if it's properly understood and we use the right equipment and implement it in the right way. So you can see that there are just a range of applications. You know, the buildings all around us are already using window automation, and our job is to make sure that it works as well as it possibly can, as cost effectively as possible. And who's using it? Well, increasingly, certainly some of the larger estate owners, a lot of the universities, office owners, and the states are looking to use as much natural ventilation as possible. And it's not just about saving pennies now, it's about delivering healthier climates in buildings, nicer places to be in, and also to reduce the carbon contribution from those buildings as well. And I think it's becoming much higher on the agenda in terms of corporate social responsibility to deliver on each of those factors as well. So it's a really kind of prominent factor in both new building design and existing building renovation. Which brings us to, of course, our discussions today. So why would we want to automate that natural ventilation? If we compare it with just having manual windows, automated ventilation really helps us to squeeze the best out of the building performance. It allows us to monitor the spaces, and of course, if we can monitor them, we can manage them with the right automation, and we can conduct routines during the day and during the night without depending on people to open and close those windows. And that means that we can take advantage of some smart strategies like purge ventilation, night cooling, and preempting poor room conditions to be able to make the building perform to its absolute best without the need for additional systems which would use energy like mechanical ventilation. It also allows us to use natural ventilation in the hybrid approach, working in harmony with other systems like heating, mechanical ventilation, and perhaps solar shading, so that we can squeeze the absolute best out of the building performance. And by automating that process, we can also make our buildings adaptable. You know, we can change routines. Hopefully we're seeing a reduction in the amount of pollution in city centres and potentially noise as well, with more electrification of transport. And that means that there's the potential there that in the coming few years, we will be able to even further harvest the benefits of natural ventilation in our buildings. So what makes up a typical window automation system? So the core components, I'm sure you're familiar with. We've got window actuators, we have got motor controllers or some sort of a 24-volt power supply. We've got the BMS itself, of course, the logic that's built into that BMS to help it to operate according to the room conditions, and then the weather station and sensors which monitor the overall building and help us to make control decisions for each of the different elements of the building. And so what are the common challenges then that we see with window automation, intelligent natural ventilation? I think probably the biggest one is the kind of the mixed bag of third-party products that traditionally make up the overall system, and pulling all of those together can be time-consuming in terms of design, procurement, installation and commissioning. So that's one element of it, that there's lots of different devices that go together to make up the overall system. part of the challenge can be that it sits between disciplines, so it's part of the facade, it's part of the windows, it's part of the main builder's package and the architectural design. Equally, there's a lot of electrical elements to it and mechanical. It's part of the mechanical design package. And it's important that we bring it all together and we take a holistic approach so that all of those components complement each other and work effectively to deliver a really high performance building, and they do it cost effectively without kind of hidden problems to go and fix later on. In terms of delivering the actual BMS control, the logic is relatively complex compared to kind of simpler control of maybe lighting or heating, which is relatively limited in terms of the number of factors that we have to take into account. With automated windows, we have to consider a number of different variables. So we're looking at things like outdoor temperature, room temperature, the CO2 levels in the room, and then we need to factor in wind speed outside, and of course the desired set points that we're trying to achieve. And so the logic needs to be effective, but it also needs to be fairly cautious. We've got quite wide-ranging control. Windows typically have quite a broad range of opening, and we need to understand that when it's very windy and cold outside, we probably need to be a little bit cautious about how far we open those windows, and we need to limit those windows and exhibit a high degree of control over the amount of ventilation so that we don't cause problems with drafts and unnecessary heat loss. Equally, in the past, there's been a lot of projects where noisy actuators have been blamed on the BMS, even if they've been procured through the window package, but of course it's part of the BMS control. So it's important that we understand these factors and we design in the right components to avoid noise issues and acoustic issues. And one of the other things that's commonly raised is, if we're night calling a building, how do we do that securely? What sort of assurances can we give the client that we know exactly where those windows are and that we're able to limit the openings so that we meet their security requirements? And of course, traditionally, it's been quite difficult to achieve feedback on the system apart from what we get from the sensors. And that means that quite often, if there is an issue, if the control algorithms aren't optimal, we don't know about it until the sensors indicate that the space is in some way not meeting the optimum conditions that we're trying to achieve. And then we readjust the system and then we wait and see what happens. And maybe there's a slightly better way of doing it. So there's lots of different ways of implementing window automation, and we're going to take a look at probably the most common, and this is kind of a traditional approach to window control where you've got your BMS, and this can be any of the big systems guys, and they want to get the best performance out of their system that they can. So you'd have your BMS, you'd have your weather station to monitor what's going on outside, and your room sensors. And here we're just looking at a single bank of windows, and you can see typically we might have a keypad input to the BMS to allow the users to override the windows, and we would have a 0 to 10 volt raise lower device or something similar that the BMS can then output a 0 to 10 volt signal to, and then a power supply unit. And that's for each bank of windows. That's typically the arrangement that we have, and at this level it looks fairly simple, no issues there. But if we take a look at actually from a schematic level, you can see there's quite a few terminations, bit of wire in there, but it's all right. We're looking at it simply from a single bank of windows perspective. It's okay. But then when you start to bring multiple rooms and banks of windows into play, the system can start to become more complex. And that's just something that we need to be aware of. There's a lot of components there. We've got to buy them, we've got to find space for them, we've got to install them, we've got to design the system first, and then of course we've got to terminate and make the system work afterwards. And then if there is an issue, we need to identify potentially where it is, and then of course we need to consider the maintenance perspective as well. And if you did want to know from a security perspective whether or not the windows are closed at the end of the day, you then have to add in read switches or something similar on the windows to understand. So we've got, you can see quite a lot of windows there, and that's based on just 16 windows there. So when you start to look at a typical school that might have 20 classrooms with, I don't know, 2 banks of windows per classroom possibly, you've got a lot of devices, that's a lot of cabinet space, and that's a lot of design work you've got to do. Nothing wrong with that, but that's the traditional approach, and it's important to understand that, and maybe some of the latest components will make it a little bit simpler for us. Another thing to consider is the operating tolerances using this kind of traditional 0 to 10 volt approach. It's fine for delivering kind of base level of automation, but when you're using lots of components, lots of cabling, and you're outputting 0 to 10 volt devices, which are then bouncing those onto power supply units, which are then bouncing them onto actuators across lots of field cabling, potentially you're looking at very short run times of kind of half a second or a second at a time, and nobody can be really certain what position the windows have actually arrived at. And that's kind of one of the issues, is that if you implement a number of different positional changes, you're never quite certain where the windows are, and therefore you're never really certain of how much ventilation you're delivering to that space, or indeed for smaller sort of trickle vent openings, whether or not the windows have even opened at all. So that's just something to bear in mind. 10-20 millimeters at a time is probably about the most accurate that you can get, and in cold, more challenging weather conditions, we need to be able to operate at fairly accurate small trickle vent openings to be able to deliver a high level of comfort and performance to the space. So more components is cost, it's complexity, it's space, and it's also potential maintenance requirements as well. So here, if you have a look at the screen, we've got an example for just 20 windows. That might be 5 classrooms or even less in a school in 7 control groups. And so when you look at the shopping bag that we've got for these components, we've got 7 raised lower devices 0 to 10 volt. We've got 7 independent power supplies for each of those groups of windows. We've got 7 switches which need to be wired back into the BMS, and that means we've got a total of 14 BMS inputs and 7 outputs, which is then going to require the relevant number of input and output modules within the main BMS panel. So what's the alternative? And today we really want to take a look at some of the latest technology which can really help to simplify and enhance window automation by the BMS. Really get the best out of the BMS systems that you've got, and piggyback on the technology that the big system guys are offering. The likes of Siemens, Trent, Schneider, Distech. They're all offering some really fantastic products. And Motorlink really sits very well alongside those to get the best out of their systems, as well as delivering a high level of building performance. So Motorlink controllers we're going to take a look at today. They're network-based controllers and power supplies that can handle native BACnet, KNX, or Modbus communication. And they can be used with WindowMaster actuators, or they can be used with almost any third-party 24-volt DC actuators as well. So imagine, if you would, that you could replace all of these components with just one of these Motorlink controllers. And imagine actually that in doing so, it would actually save you money. We've done a cost comparison, and just at a component level, one of these controllers, which can operate up to 20 actuators, is actually potentially a cost saving over the bag of other components that you would need to use if you weren't to use this technology. And then if you take into account savings in design time and cabling and termination and implementing the system, overall there's some potential cost gains as well as performance gains. And if you would imagine that then that controller can simplify the system architecture from the traditional arrangement that we took a look at a moment ago, something as simple as this. So you've got a number of banks of windows which are wired directly into the controller, keypads, override keypads directly into the controller, and that controller then sits on the BMS network and uses simple percentage position commands to control the groups of windows over the network. As I said before, most people would associate our Motorlink controllers as only being for use with WindowMaster Motorlink actuators, but in fact they have the capability to control almost any 24-volt DC motors. So now we'll take a quick look at how it works with third-party devices before we take a look at how it can work and the enhanced functionality that we get when used with motor-link actuators. So you've got any 24-volt DC motors on the windows. Each of our motor-link controllers is connected to the BMS network, and it's assigned its own BMS IP address. Sorry. Each controller can have up to 10 motor outputs. We call those motor lines, and each of those would typically have up to 4 motors connected up to the maximum capacity of the panel, and our panels come in 10 amp or 20 amp versions, so you could have a single panel controlling up to 20 windows. Using the touch screen then within the panel, the motors are set as 24-volt motors, and you simply set the stroke time of each of the motor lines, or all of the motor lines if they're the same motor and stroke. And the controller also has a number of physical inputs that you can wire keypads into, and they're connected to the corresponding input to the motor line for which you want to override the window automation. And once the BMS finds those controllers on the network, it can then begin to write simple position commands to each of those motor lines to control the actuators and the windows. So how does that take place? So communicating with the motor lines. Each motor line has a unique object for each of its functions, and those objects can either be written to, or they can be read for things like status. And they would do that over the whatever the protocol of the network was that you're using, but typically BATnet, KNX, or Modbus. And you would do that using the corresponding controller address and the object specific to the motor line that you wanted to control. So for example, the most common objects that we would see used by the BMS to control those motor lines would be auto position. So that's typically the position that the BMS logic is choosing for kind of automatic control through the day of the windows. It's what it chooses based on the room sensors in terms of CO2 levels or temperature. So that's the automated position that it wants to go to. And then we also have another object, which is a max position, and this is a limiting position. This is what we use to prevent things from happening, typically where openings would be greater than we would want them to be. So for example, if it was in bad weather, we could use the max position to stop the auto position from driving windows past a certain buffer limit. So we could set a max position so the auto position never went past 10%, 5%, 20%, whatever you want it to be. And we can also use that max position to close or limit the windows at the end of the day or for night cooling routines. And as I mentioned before, there's additional functions also available when you use our motor-link actuators, but for now, let's just concentrate on any third-party 24-volt DC actuator. And on the right there, we've just got a simple list. So you've got a controller with an IP address. It's got 10 motor lines on it, and then it's got an auto position object that you can see listed there, different object for each motor line. And then you've got a max position object, again, one for each motor line. Of course, within the head end, then you've got your programming. So typically the BMS logic is written based on the description of operation for the specific project and the set points that the client wants, and of course the desired logic, which to take into account things like air quality, room temperature, and then different weather factors. And the BMS then writes those values via BATnet or the other relevant protocol to the relevant controller IP address and the associated motor line that it wants to control. So normal routines use the auto position, limiting routines use the max position. So an example routine here. If we think about maybe a typical small classroom, motor-link panel 1 has a number of motor lines connected to it. And motor line 1 is 4 windows on the classroom facade. Motor line 2 is 2 roof lights in the same classroom. Object AO31 is the auto position for motor line 1, and object AO32 is the auto position for motor line 2. So imagine, if you will, that the CO2 in the classroom starts to increase and the BMS decide that it wants to open the facade windows to 10% and the roof lights to 20% open. All the BMS has to do is send commands to the relevant controller IP address and the control objects for those motor lines. So the BMS would send a 10% position command to object AO31, which is the auto position for the facade windows, and a 20% position command to AO32, which is the auto position for the roof lights on motor line 2. And the controller, the motor-link controller, then knows their 24-volt DC actuators, it knows what the stroke time is, and the controller then sends those actuators, powers those actuators for the correct amount of time to send the windows to approximately the requested position. Really nice and simple. Example routine 2 is setting max position. So same panel, same classroom, 4 windows on the facade on motor line 1 and 2 roof lights on motor line 2. This time the weather sensors indicated it started raining. So to prevent water from getting into the classroom, the BMS wants to send commands to the relevant controller IP address and control objects to limit the window positions on the facade to 5%. So it sends a 5% position command to object AO21. And even if there's an existing auto command trying to open the windows further than that, this then caps the maximum opening that the windows are allowed to go to. So it'll close the windows down to the 5% position according to the max position set. And for the roof lights, because of obviously the risk of water getting in through the roof lights, we want to send a 0%, which is a close command, to AO22. And the controller again uses the stroke time set and sends those vents to the approximate positions required. So the max position object sets a temporary limit on the opening allowed, and it prevents manual override, so it can stop people from opening the roof lights when it's raining, and it can stop auto position commands that continue to run their algorithms in the background from breaching what is considered to be a safe, reasonable maximum opening. So in this instance, it's to stop water ingress. But when the rain stopped and the BMS is comfortable, it can then take the limit off it. It can rewrite the max opening position back to 100%, and then any auto commands or manual overrides can resume. Another typical application for max position is at the end of the day for security. So we might write a max position at 5 o'clock to all of the facade windows and write that to 0% for security, or perhaps a 5%, 2%, something like that to support night cooling routines. And we can set a maximum opening for roof lights of maybe 5%. And then again, auto routines in the background can decide where they want to open the vents up to that maximum, which is capped by the max position. Of course, for smarter buildings, what about smarter actuators? And this is where I just wanted to take a look really at the differences with our motor-link actuators. So the simplest way I think of looking at it is imagine not just powering windows open and closed, but actually talking to them. So our motor-link actuators, used in conjunction with our motor-link controllers, allow us to open up some really important extra functionality to optimize the performance of the building and occupant satisfaction, and really make our buildings just work that little bit more efficiently and compliantly in terms of keeping occupants happy and optimizing performance and control. So what's the difference with motor-link actuators? The principle is very similar, same controllers, but with a few key differences. That the motor-link actuators are wired using 3-core flex rather than the traditional 2, because that enables digital communication right between the controllers and the actuators, and therefore it means that the BMS can now communicate directly to that group of actuators rather than just to the controller. And in terms of setting them on the panel, motor-link actuators are actually automatically detected by the panel, and that then enables the two-way communication between the window motors and the BMS. And probably one of the biggest factors and one of the most common complaints about a whole array of actuators out there is noise when they're being automated. And the first kind of big step forward by using motor-link actuators is that we can operate them at different speeds using motor-link. So when we write those auto positions that we talked about a minute ago, instead of that doing that at a fixed speed, we can actually do that at a far reduced speed, and that helps to keep the noise of the actuators right down to below background level, almost silent in the background when we're using automated functions. And that means the BMS can do what it needs to do in terms of window automation, but without intruding on the people in the space in terms of learning or meetings, and it can be done really nice and quietly in the background. However, other functions like keypad override, or if we're writing a max position because it's just started raining, can react much more quickly. It doesn't matter if there's a short period of noise when we're trying to prevent water from getting in, or for example, for fire applications, we're trying to ventilate smoke from a space, we'll operate the windows much more quickly. Similarly, if you go to a keypad and you press it to override the windows, you don't want to be stood there trying to work out, are the windows actually opening? I can't hear them, they don't seem to be moving very fast, so we can operate them much more quickly to react to the user input. But certainly our latest actuators really super quiet. Our true speed actuators, yeah, less than 30 dB typically. The other benefits of motor-link actuators are that we've now got this kind of two-way communication between the window actuators and the BMS. So that means that when the BMS sends those percentage position commands, whether it's to the auto position or to the max position, it's not using a timed power to the actuators. It's actually instructing the actuators to go to a specific percentage position. It does it absolutely and very, very accurately. And that means that we're not guessing anymore about how accurately we're controlling trickle ventilation or night cooling limits, but we're doing it very, very specifically. The other benefit of two-way communication with the actuators is that we can actually monitor the window positions. We can monitor the actual position object on the motor line, and that will tell the BMS the exact window positions and whether the actuators have been manually overridden. And that helps us to understand whether or not perhaps the operation of other systems like heating. So for example, if you've got the heating on and people are continually overriding the windows open, that would tend to suggest we have the opportunity here to dial down the heat setting, turn the heating off, and actually save some energy here. Equally, we can stop them from overriding windows by using the max position command when we want to mechanically ventilate the spaces. You know, we've seen a lot of buildings with hybrid ventilation, and we need to make sure that the natural ventilation works intelligently and in harmony with the mechanical systems to get the best out of both of those systems. So that two-way communication, that actual position feedback is really useful. And of course, at the end of the day, we don't need to use read switches because we can just read back from the motor lines what the position is, send them to max position of 0%, and we can read back that the windows are indeed closed, and we've got positive affirmation that the windows are closed and the building is now secure. There's also the potential for other objects, if we wanted to read those. So for example, we could use that for reporting system faults or errors on the system, which could be used for preventative maintenance. The finding motor-link actuators is now really easy. So if you want to explore actuators, I know that typically BMS guys don't have much opportunity to influence which actuators are used on the windows because they're normally designed and procured through a separate package. But if the opportunity is there and if you understand the benefits of them, quite often there isn't a cost implication for having that extra technology because of some of the other benefits that we get. So our website on the homepage has got a really nice actuator finder tool, and it's a very quick and easy way to get an idea of which actuators you could use that feature motor-link technology. And then just to take a quick look at the other control objects that are available. There's a number of different objects that we haven't talked about, but are there if they're required for additional functionality. We've just looked at the typical ones, but there are a number of other objects, and we can use those should we need to if there is project-specific requirements. And the next thing that we haven't yet touched upon is that our motor-link controllers, our latest generation motor-link controllers, now have the possibility of onboard logic. So as with many different systems that the BMS wants to control, the manufacturers of mechanical ventilation units and packaged systems often have their own proven logic that they can offer as a simple kind of turnkey plugin. And that one enables the BMS to do what it does best by aggregating all of the systems and pulling all the reporting back and monitoring and optimizing those different systems, but handing off some of the more complex logic as part of a packaged system. And so now we have something called MV Embedded, which enables us to effectively plug in logic within our control panels. So the BMS can now offload the decision making and the logic and just instruct our controllers to automate the natural ventilation. And our controllers themselves will use the onboard logic and sensor readings off the network to decide when it wants to open windows and the optimum position to open them to. So MV Embedded, it has a number of different levels that it can be integrated. It could be standalone, it could be fully integrated within the BMS, or it could be kind of a separate system that shares data with the BMS. There's different ways of implementing it according to the BMS preferences and the project requirements. Really simple to operate from a BMS perspective. It's almost as simple as just a stop-go process, totally scalable. We can do almost unlimited zones. The logic that's built into the controllers has been really well established. You know, we've been around for many years and have logic that we've implemented through our own turnkey systems, and it's been proven through hundreds, if not thousands, of projects. And we're now using that same proven logic on board in our controllers. It has night cooling routines, some of the sort of smart ventilation strategies like pulse, trickle, purge ventilation functions. Really nice user interface if you want to use a standalone user interface, or it can be integrated into the BMS user interface. Optional CFD analysis, that's something there's a lot more focus on for optimum building control. And it can also be used for controlling third-party equipment like blinds, fans, even heating and mechanical systems if you wanted to. That option is there, depending on how you want to implement your system. But it's all about being harmonious with the BMS and giving more flexibility and making it easy to deliver proven solutions and making it ultimately more cost effective. And it also has cloud-enabled functionality as well for remote access and data aggregation. In terms of the components, effectively you've got the MotorLink controllers, and then we enable the logic on board with a dongle, which is all programmed up to suit the room requirements and parameters. We've developed a new combined indoor room sensor and override keypad, which can be a nice solution, but equally the MV Embedded could use the BMS sensors as well and share those on the same network. And we have an optional app for occupants, depending on the type of building. That's quite a nice little feature. And as I mentioned before, web-based dashboard and cloud data logging and remote access. It's a really nice, flexible solution. It's an option there if you want to just buy a simple package and give it a stop-go signal from the BMS. Really nice, proven logic, very cost-effective, easy to implement, and lots of nice features and functions. Different ways of implementing it. I'm not going to spend too much time on these slides, but effectively it can sit with its own sensors in a standalone arrangement. It can sit with its own sensors, then integrated into the BMS, or it can use the BMS sensors on their network to share the relevant information to be able to do decision making on board and within the panel. And the best thing is that the MV Embedded really is the consolidation of already proven products. MotorLink panels have been around now for a number of years. I think probably around 10 years. They're well proven as a component, and the logic itself has also been implemented in many of our other systems that we've had for a number of years. So this is really just bringing the best of what we have in other parts of our business together and offering it as an onboard, simple, cost-effective solution. In terms of other technical info, obviously we've covered quite a lot there, but our website's got some really nice information available on it. If you were to search for WCC, we call our controllers WCC 320 or 310P plus. That's the MotorLink version of our most common controllers for BMS integration. Lots of useful information on there. really nice compact units, and there's some downloads, product data sheets, there's installation instructions, integration instructions, PICS lists, all manner of information. So you can go on our website anytime, look for WCC 320Ps, and you'll be able to get all of that information at your fingertips. If you're not sure, of course, just drop us a line. We're really happy to help. We've got a really nice team of guys that are really friendly, and girls for that matter. And they're always happy to help. Lots of good experience within the team. So just drop us a line. And actually, probably before we finish this, it's worth mentioning that you might not know that our smoke panels also have MotorLink technology. So if you've got a large atria, for example, and you want to take advantage of the best that natural ventilation can offer and smoke ventilation, then give us a shout about our smoke panels with MotorLink technology as well. And actually, we've got some really nice new compact controllers which have got Bluetooth capabilities. So again, something that's just worth knowing about. There's quite a lot going on. We've got lots of new products coming up and lots of really good, useful information as well. So find WindowMaster on LinkedIn and follow us, and we'll keep you informed then of the new and useful products and information that we can share with you. And for those of you that haven't worked with WindowMaster in the past, we're a very well established group since 1990. Our headquarters are in Denmark, and our manufacturing in Germany, and we take real pride in really high quality, really robust products and solutions. We've got sales offices in 6 countries, now with 2 in the US. And we've manufactured over 1.5 million actuators that are automating our buildings out there and making them perform even better, quietly, more accurately, and certainly a good number of those are via the BMS. And you know, we're keen to support you for more outstanding buildings going forward. And we've got a great team with lots of experience and some really good market-leading technology available. In terms of design support, as I say, we've got a number of guys that really experienced, really knowledgeable, really happy to help. Give us a call. It doesn't cost anything to pick up the phone or ping us an email, and we're happy to have a look at your project requirements. And whichever system it is you're using, you know, we're speaking to a lot of the system houses out there, and we're having some really good dialogue about how this complements the technology that they can offer. You know, it is really complementary. So yeah, lots of experience from thousands of projects, and we are here to help. You know, that's what we're all about. So just finishing up then, how am I doing on time? Oh, not bad. So you can find us on LinkedIn. Please do follow WindowMaster. Feel free to connect with me, Tom Lim, and there's the contact emails there if we can ever help. And I would like to open up the floor to questions. But before I do, actually, there's a quick thank you I'd like to make, particularly to Paul Martin at Energy and Technical Services. He gave me some really good technical input on bringing this presentation together, and equally to the guys at Siemens and Distech and SSE. We've had some really good conversations, and we're all about working with the, you know, the BMS integrators and manufacturers out there to make our buildings sing really and absolutely get the best out of. So I don't know if there is any questions at all.
Yeah, we've got some questions, Tom. So
nice easy ones first, please.
Does your MV Embedded integrate with data for outdoor air quality, so for open and closing of windows?
It can do, yeah, absolutely. I mean, there's a whole range of sensors available now for outdoor and indoor, and there's no reason why we can't incorporate that with MV Embedded, yeah.
Okay. You mentioned the example of where, with rain, where the BMS sends a 5% opening command to the window. Does this mean that the windows can remain open to a small degree when it's raining or cold? And what are the benefits of this?
I would say, yeah, it depends very much on the conditions. If you've got very high wind and lots of rain, you know, horizontal rain as we call it, then you probably want to limit your openings. It also depends on the size of the windows. It depends on the orientation of the windows, the overhang of the building. But Actually, for most of the time, we probably can open windows to a small degree. Particularly in the UK, we use a lot of top hung outward opening windows. If it was a top hung inward opening window, no, generally speaking. But this is the sort of thing we're really happy to advise on. We're not just about manufacturing and providing components. We work with design teams to try and get the best out of the building strategies and take a holistic approach. And window positioning, orientation, overall building design, we can give some input where it's relevant on that. So yeah, give us a shout.
Okay, got a few coming in now. So right, is it possible to customize the control algorithms of MB Embedded, or it works only with default control logic?
The logic that we've got built into MB Embedded is multi-layered, it's quite sophisticated, and it's been proven. And so that's what we lean on typically. It's got lots of different factors that we can set within it. So for things like purge ventilation, trickle ventilation, setting limits for security, nighttime cooling regimes, things like that. It offers an awful lot of flexibility as it is. If there is a specific requirement for a project, then I'm sure we could probably look at it, but it is probably we need to understand exactly what that is.
Okay, I've got two more, but I'll do this one first just because it's relevant to this. What generally takes precedence in terms of demand, temperature or CO2?
Good question. Well, the perception, of course, is that CO2 is the issue in winter. Typically you've closed your windows and there's no fresh air coming into the space, particularly in a classroom or an office where you've got high density of occupants. There's a lot of CO2 being breathed out, and you want to then open the windows to bring in some fresh air, and you need to do that normally quite carefully because of outdoor conditions. So typically in winter it's CO2, but there is a slight caveat to that. Our buildings now, new buildings, are so well insulated and typically fairly densely occupied that potentially you could have no heating demand down to outdoor temperatures of 5 degrees or even less. So we can address overheating issues as well in winter. But normally CO2 control in winter is predominant, and it's temperature control in mid-seasons and summer. That would be the focus. And of course, at the moment, we're also having to adjust some of our control routines to use CO2 as a metric for general air quality and ventilation rates because of COVID. Yeah, say lots of new sensors coming out, which will help us to adapt our systems to optimize the building depending on what circumstances are, whether it's pandemic or non-pandemic situation, or whether or not we just want to deliver really healthy, comfortable, low carbon environments.
Okay, Chris asked this question actually during the presentation, Tom. Can you provide or know of a secure by design window actuator product?
Secure by design is an interesting one because typically it needs a lot of testing to get the official stamp. Typically our actuators have a holding force, a locking force of 3,000 newtons, which tends to fit in with the principles of secure by design. So I suppose the answer is if there is a specific requirement and somebody wants to achieve secure by design, they're prepared to pay for that testing and certification, I'm sure that there would be, yeah.
Okay, thanks for that, Tom. Is it possible to integrate quality of life indicators for comfort, for example, or only quantitative data?
Sorry, run that one past me again.
Yeah, I thought so. Is it possible to integrate quality of life indicators for comfort, for example, or only quantitative data?
Yeah, so that's an interesting one. I mean, we've been looking at some smart building designs recently where particularly we've looked at the app at the end there that we've introduced, and with a lot of smarter buildings now, they're looking at trying to get occupants more connected with the building. So typically they're using our handheld devices, mobile phones, we're always on them. But you can poll occupants to understand if they're comfortable or not. Are you warm enough? Are you cool enough? Is it fresh enough? you know, that type of data, and it becomes much more qualitative. In some smart buildings, there's been some really interesting discussions about, you know, if we can understand individual preferences, you know, I might prefer it a little bit cooler in a room, somebody else might prefer it a bit warmer, and if we then gather our respective groups of preferences at different ends of the office, you can optimize the heating and ventilation to suit so that we're happier, but also we can make our buildings more energy efficient and more effective for the purposes they're designed. So I don't know if that answers that one, but I'm certain that that is the way that we're going to see it going. Yeah.
Okay. And is there? Oh, go on. Sorry, someone talking.
Yeah, sorry. No, and I also think that maybe the question was specific to if it's possible to integrate those quality of life indicators into NV Embedded. I mean, the app does give some feedback, Tom, but maybe you can speak just briefly to that, and if you know of any plans to integrate others.
Yeah. I mean, typically we use temperature and CO2 as an easy and well-established method of measuring spaces in terms of air quality and comfort, thermal comfort. Our understanding of that is changing. Our understanding of pollutants and the ability to be able to measure those, then that can impact quality of life and health as well. You know, even outdoor conditions, I mentioned earlier, pollution, you know, particularly during COVID, you know, outdoor pollution levels have dropped radically in city centres, and that can only improve, we hope, with measures that are being put in place by government and new design standards. And hopefully that will open up the opportunity to measure more metrics to make better decisions on how we control our buildings to optimize energy efficiency, health, and all of the qualitative stuff. We want people to be happy, comfortable, productive in our spaces, and the buildings use as little energy delivering that as possible.
Okay, thanks for that, Tom. And then there's another question here. Is there a minimum spec for other 24-volt actuators?
I suppose there's lots of different manufacturers out there, and there's a whole range of kind of cost, quality, and every project has, you know, a budget and a qualitative and performance aspiration. And I think it's important that you choose your product to suit the aspirations and the possibilities within the project. I think if I'm entirely honest, I think some of the lower cost products, and this doesn't matter whether we're talking about actuators or anything else that we purchase on a day-to-day basis, sometimes the cheapest could be a bit of a false economy, and it depends how often you want to have to meddle with it or replace it. So I think probably it's best to engage with manufacturers, good reputable manufacturers, and normally, you know, if the budget's not there, they can advise on what is possible. We do an awful lot of that. We would rather help to do proper value engineering to deliver a solution that's robust, that works, than not have any involvement in a project which potentially by using poor products, or not necessarily poor products, but not acceptable products for the building requirements, end up failing and causing problems later on. So I'd say every product's different. If you've got something that you want to look at and you want to know if it's compatible with MotorLink controllers, give us a shout and we'll happily advise. But ideally, if you engage us early, we can advise on lots of different options which could potentially deliver a better outcome.
Okay, Tom. We haven't got any more questions at this time, unless anybody's got any final ones.
That's great. Okay. Thanks, Tom and Laura, for your support, and thanks to everybody who's attended today. I think hopefully it's been useful for you. I'm sure we'll make this available on YouTube as well, so you can share it with colleagues or associates that you think might find it of use. But yeah, thanks everyone, and hope to speak to you soon. Take care.